Today we are delving into innovations in food packaging machinery. And yes, my name is Justa Vežikauskaitė from Litmea Smart Food Cluster. We are partners in EPIC Project Consortium, and will be leading this masterclass. So since today we have 4 presenters, I don't want to delay too much. And that's why I will, at the beginning, will just want to say a few words about the project under which we are organizing this masterclasses. So to do so, let me just share my screen. Mm-hmm. Could you please tell me when you can see the slides?
We can see
Yes, we can see them.
Perfect.
Okay.
Yes, let me just. So, as mentioned before, today we are joining EPIC Masterclass on innovations in food packaging machinery. And this is organized under EPIC project, which stands for Enhancing Packaging Innovation Ecosystems for Interregional Collaboration. So under this project, we are working with 9 different regions across Europe at various level of their development. And we work together with 10 partners from 8 European countries that cover different stages of packaging value chain, including machinery, materials providers, manufacturers, and end user sectors, which we are focusing on in this project, that are food, cosmetics, and health. Very briefly, we have 4 main project objectives that we're aiming at. So firstly, we are working on building capacity in innovation ecosystems of less developed regions. We are also fine-tuning the regional smart specialization strategies. We are connecting packaging value chain stages to align the demand side and the supply side. And finally, we're strengthening the potential of SMEs to identify innovation gaps and challenges. Today, we are starting the new model of the master classes that are focusing on food. So today we're talking about food packaging machinery, but we have 3 other master classes that will happen within a month from now that will focus on packaging materials and technologies, on sustainability and regulatory framework, as well as on trends in sustainable food packaging. So in case you haven't done so yet, I would invite you to register for those master classes. All information is available in our project's LinkedIn profile, as well as the links to registration forms. And in addition to those master classes, we are also kicking off with 2 other end sectors, cosmetics and health. So very soon you will see information how you could register to those master classes as well. So I would invite you to really follow the news in our LinkedIn. And returning to today. So today we have 4 great presentations on food packaging machinery. We will hear from Cristina Schiess from Heimer Packaging Technology, who will tell us about converting food waste into packaging. Then we will have Marc Vinyoles, who will tell us more about flexible food packaging machinery. We will then move on to Guillem Lloret from Mespack, who will discuss innovative and sustainable food packaging machines. And then finally, we will invite Jessica Rossi from Pack Italia to share her perspective on how their company shapes sustainable future. So now I would like to pass the word to our presenters, and just wanted to let our participant know that at the end of this masterclass we will have Q&A session But in the meantime, please leave your questions, comments in the chat, and we will get back to those at the end of the session. So for now, I would like to invite Cristina to give her presentation. And Cristina, the floor is yours.
Well, I hope you can see my screen. Okay. So, hello everyone. My name is Cristina Schiess from company Hammer Packaging Technology, and I'm happy to share with you on we are working for the last years at Hammer in innovating in the fiber molded process. Hammer is a company for more than 45 years now, based in Barcelona, and we mainly are a manufacturer for a plastic thermoforming machinery. This at the beginning, plastic and cardboard blister packaging machinery as well. And recently we have developed the technology for fiber molded machinery. So today I will talk about this technology. We are mainly focused on machinery for pulp trays, pulp containers, products for type 3 and type 4 in the food sector, which means thin walls, smooth surfaces, and in general, all products which looks like a plastic container, all for food applications. An example is what you can see on the screen, a typical food tray. For the last years, Europe is leading the market to replace single-use trays by compostable and sustainable products, all the single-use plastic trays. Raw material for compostable trays in Europe is basically virgin fiber coming from woods. In Europe, we can also find sugarcane trays, but most of them are coming from countries, they are imported from countries from Asia. So there is no local production for this kind of products. Only virgin fiber from woods in Europe. So we realized at Hammer, not only at Hammer, we realize that every year we produce millions of tons of organic waste, rich in one key material, cellulose. We use the cellulose to process it into a final product with similar properties as a plastic container in terms of oil barriers and waterproof. So just you can see the picture on the screen. This is all kind of organic and vegetable waste, and we are testing all these kind of waste on for molded products. Just imagine, for example, a tray for tomatoes. Into a final product produced with the waste of the tomatoes themselves. So this is circularity. This is cradle to cradle. And this is giving waste a new life while protecting the planet. Or for example, a paper bag for clothes made with recycled fibers from the own clothes. Or beer bagasse, this also a waste, beer bagasse to produce trays for all food applications. So our idea is giving a second life for eco-friendly packaging. This approach not only reduces waste, but also replaces single-use plastic with a compostable alternative. Here you can see, but so how is the process to get into a fiber tray with waste? So how easy is molding with this waste materials instead of virgin fiber from woods? Of course, it's not as simple as the virgin wood, but we have working for the last years strong on this workflow that you can see on the screen. How does it work? So, of course, the first step is collection and preparation of the raw fiber. As I told you, from beer, from vegetables as tomatoes, apple trees, rice, and much others. So we prepare the raw fiber. We need to grind it. Then we cook it. Then we need to rinse and clean, removing the black liquor. Black liquor is a liquid containing lignins and inorganic chemicals and other impurities. So we need to clean, of course, this waste. After this process, we mixed with water and, of course, mechanically refined to release cellulose fibers. Then we mix as well with chemical additives, or instead of chemical additive, we can mix with enzymes to provide properties to this pulp to convert in a tray or a container. The key point on the preparation for the pulp, the wet process, is to get a stable process and the uniform consistency for the pulp. Here is the machine. After the pulp preparation, here is the machine we have working on it for the forming, wet forming technology. After the process of the pulp preparation, we just connect a pipe into the machine, and the machine has basically 3 steps. We will not get deeper on this, but of course you can share. You can ask me afterwards. The 3 steps is forming. There's a tank with the slurry. We go with the mold into this pulp preparations, and by vacuum, we dry it, and then we have 2 presses for pressing and drying. The goal on the process is to reduce the humidity up to 7% of humidity. So the pulp tray at the end, the pulp tray that you can find in the supermarkets, has only 7% of humidity at the end, and of course on the traveling to the supermarket gets up to the 0. In Europe, we generate about 29 million tons of plastics. 10 of them, more or less, probably come from single-use plastic products. So the production of the pulp trays, that we are involved with, needs to cut a lot of trees as well. So in Europe, most of this virgin fiber comes from sustainable forest. But it's clear that if the market increases, this will affect, of course, our forest. So this is our responsibility. And from Hammer, we firmly believe on giving a second life to the organic waste. This is where we are working now. You are welcome to our pilot plant. There's a picture on the screen. We have a pilot plant near Barcelona, together with company SEIC Evo, This is cellulosic engineering with a deep knowledge on the, wet processes and cellulose process. We have a complete installation with a wet part for pulp preparation and a pulping machine, industrial pulping machine, which helps to validate and optimize the process based on Euro waste. So the customers can come with their waste. We can analyze on our lab. We check how to prepare the pulp, and then we can test on our own molds to check the result. So you can reach me out by email or by telephone if you are interested in further information. And thank you and enjoy the next presentations. Bye.
Thank you very much, Cristina, for your presentation. And just wanted to say that all registered participants will also receive the slides where you will be able to see the contact information of speakers. So feel free to reach out to them as well. And now I would like to invite Marc to share his presentation. So Marc, please, the floor is yours.
Okay, thank you very much. I think you see the screen, right?
Yes.
Okay, I'm Marc Vinyoles. I'm in charge of Industry 4.0 here at Comexi. And I will talk about a little bit about Comexi for the ones of you that didn't know the company. Okay, Comexi was founded almost more than 70 years ago. And it has right now, it has more than 500 employees in the world, more than 175 million euro turnover, and we invest 4% of the turnover in R&D. A little bit, well, the headquarters are here in Catalonia, in Girona, but we have also in Brazil, we have another manufacturing demo center, service sales offices, and we have also another demo center in USA, and we have service hubs in Mexico and in Thailand, and we have sales in several places of the world, close to the customers. What we do, we develop complete innovative and sustainable solutions for the flexible packaging industry. And our purpose is to provide better packaging for a better world. This is the products that I will talk now with several projects with flexo printing machines and with laminate and coating machines. But we also do offset printing, digital printing, slitting, and end-of-line of automation. And this is how we are in the value chain. In the value chain, we have a technological center, three technological centers in headquarters in Brazil and in USA, where we have all this line of machines, and we provide service because we have machines that are in service for more than 30 years, maybe. Okay, so. And now I will talk a little bit about several projects that we've done using machine learning and artificial intelligence. Okay, the first one is for flexo printing machines, and in the process of adjustment of new jobs, the machines have to position the decks, all the printers, and typically this was done by the operator or by an inspection system automatically, but it generates waste, and we are using artificial intelligence to model, to learn from past adjustments, and set the right positions, the decks in the right positions, so there is zero waste. Okay. Sometimes it's not zero, but it's a considerable reduction. Okay, the preliminary result is more than 60% accuracy with the historical operator adjustments, and now we are testing using the inspection system, which is a more consistent adjustment, and we expect to reach much better results, more than 80% of zero waste adjustments. And what we are doing is penalizing overpressure. This is because when we the adjustments that are not zero waste, we need to avoid overpressure because then the operator need to start over. So we need to select the error function to totally penalize overpressure. And we also incorporate encoder data too, because sometimes the machines are adjusted. So to not lose all and the model to be effective when there is a calibration, we need to include more data, and we are trying that as well. And also we measure accuracy continuously, and if we see that the accuracy drops, automatically we retrain the model to get the better results. So we are investing in a platform and machine learning operation platform to be able to monitor and automatically deploy a model that improves the results. Okay. So this is basically what we have to adjust for every day. We need to adjust 4 pressures: the anti-locks roll in both sides and the plate cylinder in both sides. We are trying now with a machine with 8 decks, but we will have also this for 10 decks machine. The second project is related to laminators. Right now, there are a lot of parameters, a lot of tensions in the different rollers of the laminator. And right now, we provided a recommendation, which was algorithm-based, made by our experts. But we tried to fit or train a model with all the historical adjustments, and we see that on average, the model drastically reduces the prediction error. This is the algorithm based in two models of different laminators, solvent-less and multi-layer. The drop was significant. This is an average of a lot of machines. In some machines, the drop was not so significant, or even there was no improvement. But also what we did is subsequent retraining with machine-specific data. Okay, and we see that without retraining, this is the error, and it also reduced it a lot. Okay, and right now we are in the commercialization phase, and probably in the future we will extend this for other parameters or other configurations of the machine. Okay. And finally, the last project is a project that we are in validation phase. We did this inside the project with packaging cluster, and is a project to detect anomalies. Is not for setting up the machine. In this case, is for machine health. Is for detecting that the machine needs maintenance. Okay, it's a maintenance that it's not possible to detect using a preventive strategy, because the roller wearing depends a lot, is very variable, depends on the harder the jobs, the previous jobs have been done, and it's not a notable strategy. So we train a model with unsupervised training, and requires a lot of data, a lot of time, and we need to see the data that is okay, but data that requires changing the rollers because the roller is damaged. So this happens maybe depending on the roller. It can happen every half a year or every year, so it requires a lot of time to train. And right now, this project is in the validation phase, and we don't have still results. We will have soon results, but we don't have data to share here, which is the accuracy and of the model. And that's it. Thank you very much. If later you have questions, I will be more than glad to answer. And if anybody wants to contact me, I'm more than happy to respond.
Thank you very much. Thank you, Mark. And yes, I would like to encourage participants. Feel free to ask any questions you may have in the chat. They can be to all speakers or one in particular, so we can come back to these questions at the end of the session. And now I would like to pass the word to Guillem for his presentation.
Hello, good morning. My name is Guillem Lloret. I'm the Innovation Director in Mespack. I would like to start by thanking the organization for having Mespack and my extension me here during today so we can explain a bit what we do and what's our business. So I would like to start by a Mespack introduction. So Mespack is a machine builder based on flexible packaging. We are part of a broader group, which is called Duraban, which is based in the US, in Chicago. It's divided in 4 verticals: food sorting, which would be the machines that would select, for example, potatoes by shape or by size, as an example. We have protein processing, which would be chicken deboners and this kind of machines. Material handling, which would be like the belts that you would see on Amazon intralogistics, and packaging equipment, which is where we are part of, that we are several companies that we are dedicated to packaging. Some figures about Mespack. We are also based close by to Barcelona. We were founded in 1994, so last year was our 30th anniversary. We also have a worldwide presence and a worldwide market. We are a very strong technical company. So from our 380 employees, 200 are with technical profiles. So this gives us this very technical character. And we have a very big portfolio that I will touch base very quickly. That it's the biggest in our sector. We serve different kind of customers. Today we'll be talking more about food, but we also serve pharma, personal care, home care, pet food, and also beverage. As the type of machines that we do, so we do horizontal machines that would do typical dye packs like you can see on the supermarkets for shampoo refill, this kind of stuff. Either if they come from a reel that could be made in a Comexi machine, or if they are for pre-made pouches already made and we just need to fill them and close them. We also do vertical machines, like for example, stick packs that you can see on medicines, or flat sachets like the sugar you use when you go to take coffee in a coffee shop. We also do the hydroforma line, which is the machine that makes water-soluble pots that you would use on your dishwasher or on your washing machine. And last but not least, the end-of-the-line equipment that would be the cartoners that go right after, or the boxers that you would put all this inside. So going more to the topic. Today I want to touch base of one of the more core things that we have in Mespack, which is sustainability, and some of the things that we have done to embrace that on our machines. At some point, more or less in 2018, there was a change where some laws were enforced that they would take place on 2025, 2030, where sustainable packaging would be by law enforced in Europe, and let's say traditional packaging like PET, things that cannot be recycled, would be banned. And at that moment, we started to try these new structures, and we saw that they were like an end game for us. So nothing was working, and we needed to find solutions to make that type of structures work. So what we do is we made a strategy that we call the 6R strategy, where we would embrace different things to make this happen and make this a reality in our lines. So we started by materials. The first one is reducing. So we know that flexible packaging per se is more sustainable, because if you compare a bottle to a dye pack, you are reducing more than 70% the amount of plastic that you use. But we also enhanced and did more strategies so that we could use, for example, less amount of plastic to have a higher capacity. This, we call it headspace, by filling in continuous. We also had the second strategy, which is replacing. It's changing all these materials that are not recyclable for the new ones that are recyclable, and this has some implications. We are using right now monomaterials, so combinations of different types of polyethylene or polypropylene. There is a new stream coming in today, which is PCR, so materials that have already been recycled and are reintroduced as the circular economy. With this, we can use a certain amount, around 25% on the overall material. And we also have paper. Paper is coming in and is hitting strong, and we have plenty of customers looking at that for different topics and applications. For sure, you've seen, to say a brand from Regita, Calgonit, and this kind of pots that you can see in the supermarket that they are shifting and they are coming in on paper. The last R for materials is removing. So everything that we do, which is water soluble, it disappears with water. So basically the packaging does not exist anymore. All these types of materials comes with a challenge, and we had to re-engineer our machines to introduce all that challenges. And everything that we were engineering, we also had to bring it back in the form of a retrofit. So we know that we have around 3,000 machines in the market. We could not tell all our customers that they have to throw them to the rubbish. So we needed to bring something that they could enlength that span of life for the machines. Last but not least is reusing. So we are big friends of reusable packaging, so not single-use plastic, something that you can use and reuse. That's why we look for structures that would have a spout or a zipper, something that is reclosable and that you can use on your everyday and make it a longer life for it. So which problems we found with these new materials? Basically, we have the materials that today are existing, which were working good of the machine, and the operator had no problems, but they were not recyclable, so we could not do anything with them afterwards. With the new sustainable materials, we could recycle them, but on the other side, they have very complicated machinability, especially in two things: the mechanical properties, stretchiness, they were much more stretchy, and also sealing window. So the sealing window is the difference between where you are starting to seal until it gets completely destroyed. This made us that we have to be much more precise and much more specific on how we apply all this. We, let's say, compensate and create all these technologies and create a kit for our customers that includes all this. This is technical names. I just want to explain a bit what we did. So basically, we identified all problems that this was bringing, and we brought a solution for each one of the problems. So our customers could take all these sustainable materials, put them on the machine, and make them work. Okay, this is a very long list. I will just touch base on some of the most relevant ones. Like, for example, the Elmadur sealing jaws. Elmadur is a copper alloy that has a very low temperature dispersion. This means that along a metal bar, the temperature is changing very few along it. So as you can see here, it's plus minus 3 degrees Celsius. If you use a standard iron, you are talking about plus minus 14. So you see that the values are much more narrower, and this helps on when you are transferring all that temperature on your system, on your film, you are much more precise, so you can work with materials that has a very smaller sealing window. Same with the zipper sealing. This is one of the biggest problems. So when you seal the zipper on the vertical seals, there is a change of width. And this change of width really, it's a pain because it creates a lot of tightness issues. So we have to use crushers. So it's something that is pushing there and making it flat. So it will be completely sealed. So we had to change also how we did this, the shape of this crusher, because if you were using the ones we had before, we were puncturing the material and creating leaks. So we had to make them with a different profile. Another one that was very big and was one of the most complicated to solve was how to seal a spout. So imagine a spout, it's a big piece of plastic that has a lot of temperature inertia. So when you want to seal through the film and melt it with the spout, it was happening that you were completely burning the film before you were even starting to melt the spout. So what we did is create a preheat, which is basically, if you will, like a hair dryer. So it's something that is blowing air that it's very hot, and we were preheating all these spouts. So instead of inserting the spout at room temperature, we are inserting it at 80, 90 degrees Celsius. So the delta that we need to apply to seal it, it's much lower. And last but not least, to enhance the tightness, we had to duplicate the bottom seal. You see on the drawing on the right, there is a dotted line. That is what we call the triple point, and it's the place where we have plenty of leaks. So we needed to also enhance that and have a tight pouch. And we did that by duplicating the bottom seal. The last slide that I have today is, I think, the thing that really made us different with our competitors. So the approach that we did and that we still have is that we know that we could not do this by ourselves. So what we did is we looked for the best partners in class for each of the different segments, and we made strategical JDs with them. So we would develop things together. And in this case, we saw that 1 + 1, it's not 2, it's much more than 2, because combining the know-hows of these companies plus our know-how, what we did is get to a final solution that was much better than anything we could develop by ourselves or they would do by themselves. So that's it. Thank you very much.
Thank you very much, Guillem, for presenting Mespack and your experiences. And I would like to invite the last presentation of today, Jessica Rossi, to present Ciropac Italia.
Okay. Can you see the presentation?
Yes, perfectly.
Okay, thank you. Good morning, everyone, and thank you to EPIC project organizer to invite me in this masterclass. My name is Jessica Rossi, and I am a research and development engineer in Ciropac Italia. And today I'm going to describe to you some innovation that we are doing in Ciropac to reach the sustainability of food packaging. Briefly, I want to tell you about something about Ciropac Italia, that is a small company in Italy. And in the last 24 years of activity, it has developed several innovative machineries, particularly in the food and the pharmaceutical sectors. Ciropac had installed more than 3,050 machines in 25 countries all over the world. One of the most strong characteristic of the Ciropac machineries is a high level of customization that is allowed thank you to the realization of several steps internally of the company, starting from the design of mechanical components, the construction of the software of the machine, and also the after-sale assistance. Thanks to this high level of flexibility, Ciropac machineries make it possible to make automatic and feasible some specific operation that in some cases are still manual, such as the application of bubble wrap or absorbent paper on food trays, but also the application of label and components like fork in trays that are used for ready-to-eat product. Now I want to tell you about the core mission of Ciropac Italia, that is the fact that innovation aims to achieve a full sustainability that cover different aspects such as environment, employees, machine user, final consumers, and community. So now we can see that the first aspect of innovation in Ciropac machineries is related to environmental sustainability. First of all, I want to say you that zero pack machineries can work with all the materials of food trays. So, for example, plastics, but also paper and compostable materials. But we can see that our customers are still linked to plastic packaging because it has very numerous advantages that at now it is difficult to be overcome with other materials. In this context, we can take the PET trays that are the most promising plastic packaging, and the aim of Zero Pack Italia is to boost the optimization of plastic end of life, improving their recycling. According to the data, we can see that even if there is an increasing attention of PET trays and the recycling, still now more than 70% of the value at the end of life is lost. And the big problem is that there are very complex design about these trays and a great customization that make their sorting and the contamination very difficult and consequently also their recycling. In this context, Zero Pack aims to increase the use of PET trays for food packaging, overcoming the issue about the sealing problems, because to reach the monomateriality, we have to eliminate some layers of plastics, such as PE, but it make the sealing of the film over the PETs more difficult. Consequently, Zero Pack developed the Respect technology that is a technologies that pre-treat the edge of the PET trays to eliminate all the layers of different materials that prevent the sealing of the film, and added some adhesive that not prevent the PET recycling to reach an increasing recycling of the PET trays. Another point of innovation for Zero Pack Italia is the traceability of food and food packaging. There are different drivers that make the traceability of food along the entire supply chain very important, such as the consumer demand for transparency and brand protection. But there are also different challenges to make it in practice. For example, the fragmented supply chain in the food sector and the difficulty to integrate different technologies to allow the full traceability. On the other hand, there are also several technologies that make it possible. In this context, always in the context of Respect technologies by Zero Pack Italia, the company have developed a system that allow to collect automatic data from packaging, adding luminiferous substances in the glue for the trays, able to separate good and not good trays, and to associate a specific code to each good trace. In this way, it is possible to trace every good trace along the supply chain. This the recognition of the food trace is allowed by artificial intelligence. The last point of innovation by Ciropac Italia is about the work well-being. In the food sector, but in general, in all the industrial sectors, we are facing very big challenge about high turnover and employees shortage. And now it is necessary to implement different strategies to avoid this issue. And it is required to company to well define the organizational culture and the values of the company in relation to the relation between, for example, productivity and well-being of employees. So also in this context, Ciropac have developed a system, a complete system that respect the point of the concept of the Industry 5.0, because the aim is to balance the productivity of the machine according to the psychophysical well-being of the operator. So the concept is not that the operator can adapt his health to the machine, but the machine can increase or decrease its speed according to the status of the operator. For this innovation, we had a first experiment in our company with our operator. The last point is a tool that Ciropac use to boost its innovation, that is patent and trademarks. It is not so easy for a small company to make some these numerous patent, but for each innovation that you see before, Ciropac has a patent that is already granted or under evaluation, but with positive evaluation, both in national and international level. So patents are a very effective tool to support innovation, because they have the potential to collect other resources to incentivize other innovation. And that's all for me. Thank you for the attention.
Thank you very much, Jessica. And yes, now you could stop sharing the screen. And now we've heard the 4 presentations touching upon very different angles, I would say, for food machinery. And now I wanted to give the floor to your questions. So far, I see there are none listed in the chat. Now I can see that Nicola just posted. So maybe Nicola, you can just voice it yourself.
Hello.
Yeah.
Hello everyone. Thank you very much for the presentation. Really interesting. Actually, mine is just more a curiosity overall as the market is evolving, let's say. So the question maybe was not so clear, the written one. The idea is that since you are all producing machinery for packaging. Do you see among you are all moving towards more sustainable the application of more sustainable materials in packaging? Do you see among your customers like an acceptance of this transition, like an overall acceptance of using new materials, or there is still some, I don't know, obstacles, some maybe cultural obstacles or whatever that, let's say, is how you say is being it's enhancing the difficulty in this transition. So the idea, I don't know if it was quite clear the question, but basically, what's your sentiment? What's your idea about the final market? If there is something quite flawless, or there are some obstacles in the path? I don't know what's for everyone or for none. I mean, whoever wants to answer. Yeah, Cristina, thank you.
Yeah.
Oh, sorry.
Yeah, thank you, Nicolo. From my point of view, or what affects our company, I would say that moving from a single-use plastic container to a pulp tray, whether virgin fiber or waste pulp, the major problem, let's say, is the price. Still the price. Okay. So it's true that in Europe, all of us want to go for a more sustainable process and products, but still the price is a big barrier. It depends on the countries, of course. Europe is very big, but this is my feeling. And a second point is on technical properties of the material. I mean, the regulation in Europe is going to sustainable containers for food applications. But of course, we all know that a piece of meat, it will not last the same time in a plastic rPET than a pulp tray. Okay. We can talk about rPET or virgin PET, but again, this is another discussion, is also the price. Nowadays, rPET is more expensive than PET in Europe. So, I mean, is a discussion that we could talk about these hours and hours.
Okay, clear.
This is my point of view, my opinion. Thank you.
Yeah, and I see Guillem would like to add.
If I may, I'm very aligned with Cristina. That is the cost. From my point of view, that is Europe and that is the rest of the world. So it's two different cases right now. On Europe, or this is in general, volumes for sustainable materials are not the same as for non-sustainable. Then price, as Cristina is saying, it's a big issue because you don't have the same production, so costs are higher. In Europe, it's trying to compensate it with the EPRs. We will see how this will be applied and what will be the future for that. In the rest of the world, it's not like this. So we see clearly that our customers, they are willing to embrace it. But I feel that it's more for legislation and maybe for marketing rather than because they are very thrilled to do it. Because they see that there is difficulties, there is a higher cost, and really it's not a decision that they have to take lightly because, as I explained, you need retrofit. So the same machines that you already have, they do not work for new materials, so they have to put capex and they have to enhance machines. So at the end of the day, it's a decision that it's not easy for them. And what we see is that big tier one customers, like the big CPG multinationals, they are doing it and try to be consistent all over the world because it's reputation, it's marketing. But tier two companies and smaller companies, they are not too much on it yet.
Okay. Thank you very much.
Okay. So we have another question in the chat. Maybe I will just read it out. It's aimed at Cristina. So there is a question from a company perspective. What measures do you take to ensure the safety of food contact packaging derived from organic waste, specifically regarding overall or specific migration and regulatory compliance, for example, testing protocols, certification, controls? You're muted, Cristina. Yeah, we can't hear you.
Yeah, it's a very good question because it's the key point. There are two key points on our process. One is the technology by itself, and the second point is this one: how to get the food approval for a food contact, right? So of course we have to check one by one on the waste material. And it has to be on the process with additives. We try to avoid chemical additives and go with enzymes. It's not always possible, but this is why we have our lab to investigate case by case. Okay. It's not the same using rice than clothes and beer or whatever. And also this is one point, and the other point is we need to get the approval, and of course is taking care of the application. You will okay, the use you will give to this type of container. Means it's not the same for fresh food. This is more complicated, for example, meat, than tomatoes or vegetables. So there are many things to consider here, and that we struggle to get the food contact approval for this kind of food. And balance with additives. I hope I answered to your question.
Yeah, I see the one who asked thanked you, so I think, yeah, you did. And seeing that we are approaching the end of the masterclass, I wanted to invite maybe one last question. You don't need necessarily to write it in the chat. You can only open your mic and ask. And in case we don't have any further questions, I wanted to thank all the presenters for finding the time and sharing your experiences and your insights with us. I think there was a lot of food for thought, especially for EPIC team and for our further project activities, but I'm sure for other participants as well. And I wanted just to invite you again to our upcoming master classes. We still have quite a few master classes planned. So please follow the news on EPIC project in LinkedIn. And we really hope to see you there. So thank you very much, everybody, for attending, and have a nice afternoon.
Thank you very much.
Thank you.
Have a nice
Thank you very much to
Bye-bye.
everyone.
Thank you.
Thank you.
Bye.
Bye. Thank you.
Bye.
Bye.